Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. Please press like, share and subscribe. Press the bell icon to get the notification. If you are first time viewing this channel and directly this video, then I will suggest you to go through my introduction video first to understand the presentation structure. Today we are at the operations of the matrices classes. Okay, so we are at the operations of the matrices classes. Before this, we had completed the basics of the matrices. So I will suggest you to go through that class first and after that come to this class. Please follow the sequence. Okay, so today we are at the operations class. Operations of the matrices. Okay, operation of the matrices. Operations of the matrices can be divided in two parts. Okay, I had divided it into two parts. Those two parts are taking two matrices and operating them. Okay, taking two matrices and operating them. Another part is within a matrix performing the operations. Suppose I had taken a matrix A and within that matrix I will perform operations. Right? So that is my second category. First category, what is that? That I will take two matrices and I will perform operation between those two. Okay? So those operations are addition of the matrices, subtraction of the matrices and multiplication of the matrices. Okay? So we will discuss about addition, subtraction and multiplication. In this category between the two matrices. Two matrices are there. Between that you are doing the operations. Correct? Now, this within the matrix, what are all operations are there, we will discuss in other class. Okay, so please look on to the other class for this category of the operations. Definitely we can't discuss all the operations in the same class because the video length will go on. So that's why we will discuss addition, subtraction and multiplication in this class. Okay, so what is the roadmap of today's class? Today's class we will be learning the operations of matrices. In operation of matrices there are two types, which is operation between two matrices and operation within the matrix. So we will discuss about operation within two matrices, that is addition, subtraction and multiplication. Clear? Chalo, let's move on to this addition topic. Okay, we will move on to the addition section now. Okay. Now we will see in this section the addition of two matrices. I had taken two matrices over here, matrix A and matrix B. So before jumping for addition, we have to perform first the basic check. What the basic check we have to perform is the sizes of both the matrix should be same. Okay, the sizes of both the matrix should be same for addition. Okay, what is that? Size of both the matrix should be same. If here the size is 3 by 3, here we are having 3 rows and 3 columns. So it is a two-dimensional matrix whose size is 3 by 3. We can tell it as order also. Okay, so the order is 3 by 3. Same with matrix B here. So matrix B is having 3 rows and 3 columns. Right? So it is having 3 rows and 3 columns. So it is a two-dimensional matrix with order 3 by 3. So both the matrices sizes are same. So this is the first check which you have to do in order to do the addition. Okay, in order to do the addition, this is the first check you have to perform. If suppose you are having 3 columns here and you are having 4 columns here, then you can't add these two matrices. Okay, you can't add these two matrices. Okay, earlier I told that each and every element of these matrices, are represented in the form of ij. Okay, are represented in the form of I and j, where I will give number of the column, a number of the row, and j will give number of the column. I will give number of the row and j will give the number of column. So once you add these two matrices, what will be the result? The result will be another matrix. Once you add these two matrices, the result will be another matrix. That matrix will have a element, suppose Cij. That matrix is C and elements are denoted by Cij. Okay, then how that matrix will be written? So let's see that. Once you perform addition operation, it will be A plus B. Okay, result will be C. Elements of the C can be written as Cij. Okay, these elements of Cij will be equal to Aij plus Bij. Aij plus Bij. So this is the result of this addition. Aij plus Bij is the result of addition. Now, what is the meaning of Aij and Bij? If we are taking first row and first column element, that should be added to first row and first column element of matrix B. First row and first column of matrix A will be added to first row and first column of matrix B. Okay, so the result of this addition will be the first row and first column of matrix C. Let's read it now. First row and first column of matrix C is equal to sum of first row and first column of matrix A plus first row and first column of matrix B. Okay, so let us now write the result, how it will look like. So A plus B will be, which is equal to C, it will be 1 plus 10. So you can write here first element as 1 plus 10. Second, and second column, first row, 2 plus 13. So it will be 2 plus 13. Third element will be 3 plus 16. Now C23 will be 4 plus 11. What is C22? This is C21. Next C22 will be 5 plus 14. C22 will be A22 plus B22. C23 will be A23 plus B23, which will be 6 plus 17. What is this element? This is A31, this is B31. So C31 will be A31 plus B31, which will be 7 plus 12. Okay. Now 32. C32 will be A32 plus B32, which will be 8 plus 15. Okay. Now C33. C33 will be A33 plus B33, which is 9 plus 18. It is 9 plus 18. So what will be my resultant now? My result will be 10 plus 1, 11. C11 will be 11. C12, 15. C13, 19. C21, 15. Okay. C22, 19. C23, 23. C31, 19. C32, 23. And this is C33, which will be 27. Okay. So this is 27. Close the bracket. So this matrix will be my C matrix. So this is denoted by C. So this A plus B will give us A plus B, which is this matrix, which is the C matrix. So what is the representation of this C matrix? C matrix is nothing but Cij, whereas Cij is each and every element of that matrix. Cij is equal to Aij plus Bij. Okay, now let's move forward. If suppose this column is not there, then order of this matrix will be 3 by 2, 3 rows and 2 columns. Okay, a 2-dimensional matrix with 3 by 2 as a order. Now this is 3 by 2, this is 3 by 3. In these two matrices, till these 2 columns we can find the corresponding elements, but for third column we will not find the corresponding element, because third column in matrix B is not at all there. Third column elements of matrix A are not having a corresponding elements in third column of the matrix B if this column is entirely omitted, and the size of matrix B will become 3 by 2. Hence the addition is not possible. Okay, so this is the reason that when the two matrices are of different sizes, we can't find the corresponding elements of some of its rows and some of its columns. Are you getting it? So we can't find the corresponding elements of one of the matrices to the other of the matrices in certain rows or certain columns. That's why when the order of the two matrices differs, then we are unable to add those two matrices. Okay, so this is the first check you have to do, whether the order of the two matrices are same or not. So let's have some example. If order of A is 3 by 4 and order of B is also 3 by 4, can it be added? Yes, it can be added, because both are having same order, 3 by 4 and 3 by 4. That's why they can be added. Are you getting it? Okay, chalo. So this is what the addition is. Now, as we understood the addition, let's draft some properties of the addition. What are all the properties of the addition? So, as we had done addition, what we understood from this? We had understood from this that if we take each element in an account, each number, first and second, first this one, like that, each element if you will take in an account, then we will find that it's nothing but a simple addition, how we do our numbers, right? Simple addition, which is 1 plus 10, after that it is 2 plus 13, like that. Okay, but it is in a very elegant fashion. Second element, 2 element is added with 2 3 element added with 3 right? 3 element added with 3 So such an elegant, it is a structure, that's it. Otherwise it's a simple addition. So what are the takeaways from such type of additions? First takeaway, if we add a plus b, it is also equal to b plus a. This is our first takeaway. Okay, even you do 1 plus 10 or you do 10 plus 1, you will get same result. Like that for each and every element. A1, 1, A1, 2, A1, 3, whichever element you take, all elements it will have same result. Okay, you understood this property? Let's go to next property. Next property is, if suppose we will take 3 matrices in an account. If we take 3 matrices in an account, like A plus B plus C is equal to A plus B plus C. If we take 3 matrices, you add the elements of 2 matrices and after that you add first matrix, or you add element of first 2 matrix and add third matrix. Both are same. Let me repeat. If you take 3 matrices, add last 2 matrices and after that you add first matrix, or you add first 2 matrix and then take addition with the last matrix, result will be the same. Suppose you are doing 1 plus 2 plus 3. If you add 2 plus 3 first, you will get 5. After that you add 1, you will get 6. Or you will first add 1 plus 2, which is 3. You add with 3, you will get 6. So result is same, right? So the order doesn't matter. Okay, this is the other property. Let's go to another property, which is, if we are adding 2 matrices. If we are adding 2 matrices and we are getting result as 0. If we are adding 2 matrices and we are getting result as 0, then both these matrices are additive inverse of each other. How this 0 matrix will look like? If the order of A is 4 by 4, then B should be 4 by 4 for addition. Okay. Once you add these two, the resultant matrix will have all zeros as its elements or in its numbers. Okay, all zeros in its matrix. Okay, that matrix is known as null matrix or zero matrix. We will discuss this in our types of matrices. So if you add these two matrices and you are getting that 0, then B is the additive inverse of A, or A is the additive inverse of B. Understood this? Okay. Suppose here A's element, first element A11 is 1. If suppose B11 would have been, if suppose -1, then 1 minus 1 it will become 0. Okay, so my first element is 0. Like that, if B12 will be -2, then again C12, which is the result of A plus B, will also be a 0. Are you getting it? So like that, if all elements are there such that addition of A and B will result in all 0 elements, then that is known as an additive inverse. Okay, so these three are the main properties. Okay, now let's move on to the second operation, which is subtraction. Okay, chalo. Let's move on to the subtraction of the matrices. Here, these are the two matrices A and B. Okay, two matrices are A and B. Subtraction of the matrices is same as addition of the matrices. Okay, the properties and the fundamentals all are same. Only thing is we are just subtracting the corresponding elements. What we are doing? We are subtracting the corresponding elements. Okay. This A matrix, all elements can be represented in the form of Aij. In B matrix also, all elements can be represented in the form of Bij. Okay. After subtraction, resultant matrix C, resultant matrix C will have its element in the form of Cij. Okay, it have all its element in the form of Cij. Then how it will look like? Okay, how it will look like? So my Cij will be Aij minus Bij. Aij minus Bij. Each element of A, corresponding element of B will be subtracted. In addition, that was added. Okay. Before jumping into this subtraction, what check we have to do? Same as addition, we have to check whether the order of both the matrices are same or not, whether the size of both the matrices are same or not. Here A has 3 columns and 3 rows, so its order is 3 by 3. B has 3 rows and 3 columns, so it is again a two-dimensional matrix with the order 3 by 3. Okay. Okay. So what a matrix Cij will be? Cij will also be a 3 by 3 matrix. Okay, a 3 by 3 matrix. So how my Cij will look like? So Cij, C matrix, this is C. So write it as C is nothing but A minus B. Okay, so let's write it down over here that C is nothing but the result of operation between subtraction operation between A and B. Result of subtraction operation between A and B. So C will be first element, that is C11. A11 minus B11. It is 10 minus 1. Okay. A12 minus B12. 11 minus 2. A13 minus B13. 12 minus 6. A21 minus B21. 13 minus 3. A22 minus B22. 14 minus 5. A23 minus B23. 15 minus 7. Okay, A31 minus B31, 16 minus 4, A32 minus B32, 17 minus 8, A33 minus B33, 18 minus 9, 18 minus 9. So these are all my Aij minus Bij elements. This is all my Aij minus Bij elements, which is equal to my Cij elements, and that is my C matrix. So what will be my C matrix? My C matrix, which is the resultant of the operation of the subtraction, is 9, 9, 6, 10, 9, 8, 12, 11, 9 and 9. This is what is the resultant. This is what the result matrix, which is C. Okay. Okay. Everything is correct? Yeah. Perfect. So this is what my matrix C is. Okay. Now let's move on to the properties of subtraction. Okay. So for the properties of subtraction, if you had done A minus B, then don't write it as B minus A, because it's a subtraction. A minus B is not equal to B minus A. So that is what the difference between addition and subtraction is. A plus B can be written as B plus A, but here A minus B, it's A minus B only. Okay. So its operations, the way of working, everything is similar to addition, but properties, you have to take care that there is a subtraction sign in between. Okay, this subtraction sign is as significant as you had used in your earlier classes. Okay, after that all properties are understandable. You go through your textbook and you get all the properties with you. Okay, now let's move on to multiplication. Okay, let's move on further for multiplication. Chalo. Okay, now let's start the multiplication of the matrices. This is my A matrix and this is my B matrix. Okay, my A matrix and B matrix with order 3 by 3. Okay, so A is a two-dimensional matrix of order 3 by 3 and B is the two-dimensional matrix of order 3 by 3, and elements are shown here. Okay, these are the numbers. Before jumping into the multiplication of the matrices, first understand what is the requirement for the feasibility of multiplication. Okay, like for addition, what is the requirement? Requirement is both matrices should have same order. Okay, both matrices should have same order for addition and subtraction. For multiplication, what is the first check? First check is number of columns of matrix 1 should be equal to number of rows of matrix 2. If you are doing a multiplication as C is equal to A cross B, then number of columns of A should be equal to number of rows of B. Are you getting it? So suppose A size is M cross N. Okay, what is A size? A size is M cross N. Then for a multiplication to happen, B size should be N cross P. Number of columns of A should be equal to number of rows of B. Otherwise, multiplication will not happen. Okay, we can't do multiplication. Now, there will be, after these two multiplication, there will be a resultant matrix. Okay, there will be a resultant matrix which is C. Order of C will be, what will be the order of C? So M cross N multiplied by N cross P, order of C will be M cross P. I repeat, A with M rows and N columns, B with N rows and P columns. Multiplication of these two matrices will result into a matrix which is having a size of M rows and P columns. Okay, it will result into a matrix which is having a size of M rows and P columns. Okay, so this is all about the size and this is all about the requirement. What is the requirement? That number of columns of A should be equal to number of columns of B. Why it is like that, we will understand in our next steps. Okay, once we do our multiplication. So, how to perform the multiplication of the matrices? Now, first element, which is A11, will be multiplied with B11. After that, A12 multiplied with B21. A12 will be multiplied with B21. A13 will be multiplied with 31. Are you getting it? 13 is multiplied with 31. 21 will be multiplied with 12. A21 is multiplied with 12. So 21 element is multiplied with 12, 22 element will be multiplied with 22, 23 element will be multiplied with 32. Just 23 in this, 32 in that. If suppose 31 in this, then 13 in that. Are you getting? Those all will be multiplied. Getting it? Okay. This is how multiplication will take place. Now, once you have done the multiplication, now you have to add the elements. How to add the elements and how to write the matrix is here is its way. Suppose C matrix you have to write. So, you have to write R1 C1, R1 of A and C1 of B. This will be the R1 of A, R2 of A, R3 of A. This will be C1, C2 and C3 of B. This R1 and this C1 you have to multiply. So it will be 0 into 1, 0, 1 into 0, 0, 2 into 2, 4. So 3 multiplications you had done, add these 3. So you will come up with R1 C1 as 4. Like that you have to do. Next one is R1 C2. Next one will be R1 C2. After that R1 C3, R2 C1, R2, C2, R2, C3, R3, C1, R3, C2, R3, C3. This is what is the multiplication. Row of A should be multiplied with column of B with the corresponding elements and summed up. Okay, so this is what is the chart for getting multiplication result. Okay, result is denoted by matrix C. Okay, so you will get this as a result. Okay, now let's perform multiplication of these two matrices. So your C matrix, I will denote it by C. It will be R1 C1. R1 is 0 1 2. You multiplied with C1, which is 1 0 2. So 0 into 1 plus 1 into 0 plus 2 into 2. This will be my first R1 C1. Now next go to R1 C2. So R1 C2 will be 0 into 2 plus 1 into 1 plus 2 into 3. 0 into 2, 0 into 2, 1 into 1 plus 2 into 3. These all added together. Now R1 C3, this R1 and that is C3. It is 3 into 0 plus, okay, next 1 into 2, 1 into 2 plus 2 into 4 plus 2 into 4. Okay, so what we have done, 0 1 2 is multiplied with 3 2 4 respectively. 0 is multiplied with 3, 1 is multiplied with 2 and 2 is multiplied with 4 and all are added. Similarly, now you have to do for R2 C1, R2 C2 and R2 C3. So this element will be R2 C1. So it will be 1 into 1 plus 2 into 0 plus 3 into 2. After that, R2 C2, it will be 1 into 2 plus 2 into 1 plus 3 into 3. Okay, now R2 C3, it will be 3 into 1 plus 2 into 2 plus 3 into 4. Okay, are you getting it? So R2 C1, R2 C2, R2 C3. Now you take R3 now, it will be R3 C1. So it will be 2 into 1, 3 into 0 plus 2 into 4. Now next element R3 C2, it will be 2 into 2 plus 3 into 1 and 4 into 3 plus 4 into. Okay, now next R3 C3, 2 into 3 plus 3 into 2 plus 4 into 4. Okay, so this is what will be my C matrix. Are you getting it or not? Okay, so this will be my C matrix. So at last, how my C matrix will be? You do this entire calculation. Before that, we will see how we can do it easily. So R1 C1, 0 into 1 0, 1 into 0 0, 2 into 2 it is 4. So my first element will be 4. Now R1 C2, 0 into 2 is 0, 1 into 1 is 1, 1 into 1 is 1, 2 into 3 is 6, so it will be 7, 6 plus 1 7. 0 into 3 is 0, 1 into 2 is 2, 2 into 4 is 8, 8 plus 2 is 10. So it will be 4, 7, 10. So this is, rather than writing like this, you can practice for initial questions, you can practice like this, but you should be able to put the matrix in this way. Okay. Now for row 2, 1 2 3 1 0 2, 1 multiplied with 1 is 1, 2 multiplied with 0 is 0, 3 multiplied with 2 is 6. So 1 plus 6 is 7, it will be 7. 1 2 3 2 1 3, 1 multiplied with 2 is 2, 2 multiplied with 1 is 2, 3 multiplied with 3 is 9. So 9 plus 2 is 13. 13. 1 2 3 multiplied with 3 to 4, 1 into 3 3, 2 into 2 4, 3 into 4 12. So 12 plus 4 16, 16 plus 3 19, so it will be 19. Now 2 3 4 is multiplied with 1 0 2, 2 is multiplied with 1 2, 3 0 is 0, 4 2 is 8, so 8 plus 2 it is 10. 10. 2 3 4 2 1 3, 2 2 is 4, 3 1 is 3, 4 3 is 12, 4 is multiplied with this 3, 12, 12 plus 3 15, 15 plus 4 19, so this will be 19. Now 2 3 4 3 2 4, 2 3 is 6, 3 2 is 6, 4 4 is 16, 6 plus 6 12, 12 plus 16 28, so this will be 28. So this is my matrix C. Okay, this is how multiplication will takes place. Okay, this is how multiplication will take place. Now we will move on to the properties of the multiplication. Okay. So properties of multiplication: A multiplied with B multiplied with C. Okay, A multiplied with B multiplied with C. You can take B and C at the same time, or you can also take A and B also at the same time and you do multiplication with C. Okay, so this is my first property. Are you getting it? A, okay, A, B, C are the three matrices where B and C are multiplied and then multiplied to A, or A and B are multiplied then multiplied to C, both are same. Okay, next, A multiplied with B plus C, A matrix multiplied with B plus C, you will get as A into B plus A into C. ठीक है? Is it okay? It's A into B plus A into C. So A is multiplied with B and A is multiplied with C. Okay? So this is another property. Third property is very important property. If multiplication of the two matrices results into a zero matrix or a null matrix such that all the elements on that matrix is zero, then it's not compulsory that either B is 0 or A is 0. Suppose you had taken two numbers, 2 into 0, it's 0. 2 into any other number, it will be any number other than 0. Okay, so when we are multiplying with two numbers, if any one number is 0, then we will conclude that it's a 0, or if result is 0, then we will conclude that in a multiplication chain definitely one number would have been 0, that's why I am getting result as 0. Okay, but this doesn't work in the matrix. In matrix, if suppose multiplication of two matrices is 0, then it is not a confirmation that either A is 0 or B is 0. It may be, it may not be. Okay, it may be or may not be. It's not a confirmation call for us to tell that either A is 0 or B is 0. Okay, because once we multiply the two matrices, it will depend on addition also. Okay, when it may happen that entire row when multiplied with this column and you added up, at that time it would have been resulted into 0 rather than the actual values of rows and C's to be 0. Are you getting it? Okay, so that's why when the two multiplication of the matrices is 0, it's not a mandatory call that either A is 0 or B is 0. This completes today's class, which is the operation between two matrices. Okay, it's addition, subtraction and multiplication. If you are happy with the content, please press like, share and subscribe. For the further classes, stay connected. Thank you.